use all engineering, what they call engineering materials in the RC10, which means materials that are the highest strength to weight ratio that's available, kind of things they use in aircraft and so on. So the chassis is made out of aircraft aluminum.
40 years ago, Roger Curtis put pencil to paper to design the original RC10. Now, high-end computers and sophisticated software help a team of engineers design the high-performance RC cars we see today.
Yeah, so the importance of prototyping, it's been pretty awesome in the day age of 3D printing. We can try a lot of new ideas super quickly, just due to the fast turnaround times. We can design something, print it overnight, have it ready by the next day, and then go to the track that night and do testing.
Prototyping has helped the development process of this car greatly, from inception through to nearing production. So we started out with an original design that we were able to rapid prototype in-house with our 3D printer.
But I think as far as prototyping, now we have access to CNC equipment, we have access to 3D printers. You can print plastic, steel, aluminum. You can print all kinds of stuff, but we mostly machine all the metal parts, but things go quicker now. So back when we made the RC10, it took a long time to machine every single part by hand and no CNC. Newer cars got done quicker by using CNC, and now things can go really quick because we can design the part, we can 3D print something, I can machine something within a couple days, and within a week we can have something else to go test.
This allowed us to do a lot of more extreme design choices and test out new things that may normally not be doable with the timelines that we have, right? So having that quick turnaround time and be able to do part after part and go test it and understand quickly if this is the right direction or not really helped us try a lot of interesting things and move into the direction that we're at now, and we're happy with that. So.
Yeah, we were able to try multiple iterations of like a suspension arm. We could print 2 or 3 different suspension arms in one print, go to the track for one night and determine what the different arms are doing.
This car here, we probably had more testing all over the United States than any other car that we've ever made.
We need more development time. Now that we've learned a lot about using prototype parts, so 3D printed parts for our cars. So now moving forward, that was a big part of this learning experience, I guess, for the car, was just printing parts, figuring out how to make them strong, and figuring out the flex.
It takes a lot more time for, let's say, Curtis to machine something, right, get it all in his program that he takes to the Haas and then mills it out, and then all the setup and time and jigging that he has to do to get that part made is huge, right? He has a lot of things going on, and that's his time. Versus a 3D printer, we can take a part, throw it in there, and most of the parts that we can print are going to be functional enough to understand if it's going to be good or not.
And also limitation on, if you machine something, you may not be able to mold it. You got molding parameters, how the mold opens and shuts, and so you can think of those kind of things too.
3D printing has been a big part of the design process of this car. We've been able to test 3-4 different total designs now between start to finish. It's been really nice to be able to take concepts that are completely a stranger to us and be able to understand, like, oh, this does work in off-road or it doesn't work in off-road. And we learned a lot in that initial 2 designs that were pretty outlandish, and then took what was really good from those and applied it to the next versions, and that's closer to what turned into the B7 platform.
With all the technology, new materials, and prototyping equipment, it still takes thousands of hours of research and development. So, what exactly does it take to win race after race?